Hello, good morning everyone, and thank you Anthony for that introduction. I just wanted to start out today for those of you who may not be as familiar with our company with just a quick overview of EAC and what we offer. At EAC, we are dedicated to help companies transform the way they design, manufacture, connect to, and service their products. We do this by offering engineering and design services such as software support, implementation, training, and product and part design. EAC was founded in 1996 and has experts in 22 areas of product development. We are also a solutions provider of PTC and have been a leading PTC global service provider for 15 years. At EAC, we know that engineering calculations are a critical part in your product development process, and that is why we are here today to talk about the benefits of Mathcad Prime 4.0. I will now hand this over to Angie, who is going to give us a demonstration on Mathcad.
Shannon, thank you very much. Good morning, everyone. This is Angie Severino speaking, and I'm just going to go ahead and get started with Mathcad. This is the agenda for today. We're going to start off with an introduction of Mathcad Prime 4.0 and just go over at a very high level what Mathcad is all about. Then we'll go through a demonstration of Mathcad Prime 4.0. We'll also talk about how to convert or import your Mathcad 15 documents into Mathcad Prime. We'll talk about working with Excel, and maybe not just Excel, but other forms of input data, so ASCII data, text files, Excel files. So we'll talk about how to do that. And we will also touch upon capabilities that are in Mathcad Prime that are not in Mathcad 15, so that it's clear to everybody what some of those differences are. And then time permitting, we'll also just have a quick sneak peek at what's coming in Prime 5.0. And then, of course, we'll take Q&A at the end of the presentation. So just very quickly up front, what is Mathcad? Mathcad is an engineering document. So it's an engineering document that combines live math, text, graphics, plots, images into a single working calculation file, and it looks like a document. So when we're doing our work in Mathcad, we can document what we're doing, document our decisions, our assumptions, and all of the math is captured in native natural math notation, so we can share what we're doing, communicate what we're doing in a way that's very easy and transparent to all of the people that we need to communicate with. We can analyze, we can solve problems. So really, it's the one centralized location to be able to do all of our engineering work, but then document it at the same time and have, at the end of the day, a transparent, readable engineering document that can be reused, that can be shared, that can be understood, and so on. So this is just a very quick introduction to Mathcad. On the right-hand side of this slide, we have a picture of a Mathcad document. So just remember that that's a live document. If we make changes to any input variables or design variables, those changes will propagate forward and update all of the dependencies that follow. So the plots will be updated. The numerical results will be updated. Everything will be updated. So we can make changes to our design variables, our analysis parameters, our equations, our formulas, and those changes update all of the dependencies. And then, as you can see here in this slide, that everything is readable, it's transparent. So in order to accomplish that, those two things, we use natural math notation, and we also have a whiteboard interface. So there's no structure to this document. It really is a whiteboard. And anywhere within this whiteboard, you can start typing in math content, formulas, equations, variable definitions, text content, assumptions, decisions, anything that we want to, a thought that we want to capture as we're doing our work. So it's a whiteboard interface, which means that we don't have to conform to a predefined structure. No rows, no columns, no grids, no programming, syntax, nothing like that. I already mentioned that it's comprehensive. It combines live math, text, and graphics into a single transparent document. There's two types of math engines in Mathcad. There's a numerics engine and a symbolics engine. So we can ask for numeric results or symbolic results. So if we're doing some more theoretical work or analytical work and we want symbolic solutions, then we can use the symbolics engine too. And perhaps something that's very important to mention is that the engine is units intelligent. So Mathcad knows what units are, it tracks units, it propagates units throughout calculations, it converts units, it takes care of all of the units handling and units management for us, so that as engineers, we don't have to worry about converting feet to inches. We can focus on the actual engineering problem. And then it's a document. So we have a document-oriented approach here. And then the engine is also very advanced. So we probably won't have time to go into the advanced capabilities today, but just know that there are functions for advanced capabilities, such as solving, data analysis, curve fitting, curve smoothing, interpolation, optimization problems, and programming. Okay, so all of that is there as well. And then finally, Mathcad does have an API that allows us to integrate with other applications. So we do have an out-of-the-box integration with PTC Creo, and then with the API, we can integrate to other applications as well. Okay, so I'll go ahead and pull up Mathcad Prime 4.0, and so just give me a quick moment here, and your screens will update with Mathcad Prime 4.0 momentarily. Okay, so I think everybody should be seeing this now. So we're going to go ahead and walk through this document, and as we're walking through it, I'm going to do a lot of explaining about some of the things that we're doing in this document. So this is a mechanical engineering problem where we have a bearing shaft and we want to calculate the critical speed of this bearing shaft. Okay, and so we have some input variables. And so this is what the Mathcad document looks like. Okay, so as you can see, I keep saying document, it is a document. But all of these things, all of the math pieces that are included here are live math. So here we have a couple things at the top, and these are just text boxes. All of these things are just text boxes. However, Young's modulus here is a math box. Okay, that's a math object. So we're defining an input variable E for Young's modulus. And as you can see, we're defining it with units, gigapascals. So the units, we're here on the math tab. Okay, so this environment is set up with the ribbon at the top, and then we go to the top of the ribbon and we find what we need to do and we click on it. So we're going to go to the units, and on the math tab, we're going to go to the far right and we can see a little section here for units. So it tells us that our unit system is set to the SI system. Okay, so it's very important to understand how the units work in Mathcad. We're set to the SI system. We can change that to the US customary or the CGS system, but we're going to leave ourselves in SI for now. And then this button to the left is the units library. So when we click on this, we can see a complete listing of all of the units that are included in Mathcad. And this is quite a long list. All of these units are assigned to a dimension. So for example, capacitance, farads, nanofarads, picofarads, microfarads. These are all of the units are just assigned to a dimension. And then those dimensions are listed here in alphabetical order. So we can scroll down through this list and see the units that are available to use out of the box. Now, a lot of people do ask me, what if we have a unit that we want to use that isn't here? For example, flow rate, cubic feet per minute, gallons per minute, and million gallons per day. What if we want to use gallons per hour, right? There's a big gap between gallons per minute and million gallons per day. What if we want gallons per hour or gallons per day? So if that's the case, we can define that unit ourselves. We can add it. So we can define a unit. As long as we can define it in terms of something that is in this library, then we can define our own unit. So we could define gallons per day or gallons per hour, and then we could use it. And I can show you how to do that. It's very easy. So those are the units. So we're going to include units on all of our inputs, and we're going to incorporate them into our equation. So you can see here E, and to enter that, we just type E, and then we define it, and we just assign it. And then for gigapascals, I'm going to type GPA, okay, from out of that library. So we have to go to that library and see how we want to enter it here. So there, that is Young's modulus. Now, some more inputs. So we have the outer diameter of the shaft, and it's initialized to 15 centimeters. We have the inner diameter initialized to 9 centimeters. We have the mass initialized to 15 kilograms. And then we have the length, which is the sum of these two components, A and B. And as you can see over here to the right, we have a 2D schematic. A is 50 centimeters, B is 50 centimeters. So let's keep going. So then this is a 3-step calculation, pretty basic. The first thing that we're going to do is calculate the second moment of area. So that's I. And I'll just type this in so that you can all see how we type these things in. So this is the expression for I. So I'm just going to type I over here on the right-hand side underneath the diagram. And then I'm going to define it. And for pi, we're going to type pi divided by 64. We're going to multiply that by the outer diameter raised to the 4th power minus the inner diameter raised to the 4th power. And that's it. So that is our formula for I. So now we can either type equals here to get the numerical result, and that's what we've done on the left-hand side. We've added an equal sign. Or we can come to the right or underneath, and we can do it separately. So this is a matter of personal preference. Do you want to do it in one fluid continuous expression, or do you want to display your final numerical result separately? So that's just a personal preference. I like to do it separately. So here we have meters to the 4th power. Remember, I pointed out that the unit system is SI. The reason our answer is in meters to the 4th power, even though we're dealing with centimeters here for the lengths and the diameters, is because meters is the default in SI for length. Okay, the default base unit is meters. That's why the answer is in meters. So our answer will always be given to us in whatever the default base unit is for the unit system we're working in. And so we don't want meters to the 4th. We're dealing with centimeters here. And so we're just going to come here and we're going to replace the meter with centimeters. And now hit enter. And there's the conversion to centimeters to the 4th power. Okay, and we don't have to stay in SI. We don't have to stay in SI. Let's type I equals, and let's convert this to inches to the 4th power. So Mathcad knows what those unit conversion factors are. This is incredibly powerful because it takes a tremendous burden off of the engineer to convert from centimeters to inches, to shift the decimal point when going from meters to centimeters. So it takes all of that, and those conversion factors are all built in. It takes all of that extra work off of the engineer to have to do that. Now, those conversion factors and all of the calculations in Mathcad are done with 64 bits of floating point precision. Okay, so they're very precise. Everything's very precise. There's no round off error. There are no mistakes in this engine. So everything's going to be correct. So now that we have this 51.96, we're seeing 5 decimal points here. So what we're going to do is put our cursor on this number, and we're going to go up to math formatting, and we're going to customize what we want that to look like. So if we only want to see 2 decimal points, we're going to change this to 2. If we want to see scientific or engineering notation, we're going to set that here. If we want to see trailing zeros, we're going to enable trailing zeros. And so now we've established 2 decimal points, and we've converted the answer to inches to the 4th power. Okay, so that's how it works. You click on your numerical result, you go to math formatting, you apply your formatting. So everything is based on clicking on items from the ribbon at the top and applying the operators that you need. So the next calculation here is the stiffness coefficient. Okay, and so this is simple enough. 3 times E times I times L, the length, divided by A squared plus B squared. And you can see the natural math notation here, right? This is a transparent document. Any engineer can look at this and validate it, approve it, question it, talk about it. There's no reverse engineering required when it comes to understanding this. Okay, everything is at base value. All of the engineer's work is presented at base value. So here we are. And then the next final calculation is the speed of the shaft. And that's CQ divided by M. So again, that's just, we type C subscript Q, divide that by the mass, and then take the square root. I apologize. Let me do the square root. So the square root of C subscript Q divided by M. Then we can type equals, and the default units in SI are inverse seconds. Okay, but we're just we want to see that represented in radians per second, so we're gonna convert it to radians per second. If we don't want scientific or in this notation, we're gonna come up here and we're gonna convert it to decimal notation. So now all of these things that I'm doing as far as formatting the numerical result, these can be defined as standards for the whole document so that we don't have to customize one result at a time. We can say we always want 2 decimal points of display precision. We always want decimal notation. So those are things that can be automated. All right, so here we are. So now let's change the outer diameter. We're going to change it to 18 centimeters, and I'm going to hit enter, and what you'll see is that I is going to update, CQ is going to update, and the critical speed is going to update. So I'll hit enter now, and you can just watch those numbers change. Okay, so now the next thing that we do with this problem, this is a nice problem because here we've done it with scalar values. Outer diameter takes on one number at a time, inner diameter takes on one number at a time. But now, what if we want to process a collection of outer diameters and a collection of inner diameters, and we don't want to change this from 18, then 17, then 16, then 15. We don't want to run this 20 times. We only want to run it once. So the next page here is going to do that. We're going to iterate over a collection of outer diameters and a collection of inner diameters. And instead of getting one result, we're going to get 16 results. Okay, so let me explain what's going on here. On the right-hand side, what you see highlighted in yellow here, this is called an input table. This is new in Mathcad Prime. This is not in Mathcad 15 for those attending today that use Mathcad 15. This is only in Mathcad Prime. And that is located here on the Input-Output tab. And it's called, I'm sorry, it's on the Tables tab. And it's called Insert Table. So when we click on Insert Table, we can pre-size a table here. And what's really nice about this is it gives us a way to do a quick ad hoc calculation, right? Let's just do something real quickly. Let's just iterate over some outer and inner diameters and look at what's happening. So we're going to give our left column a title. That would be capital D, outer diameter, okay, or OD. And then on the right-hand side, ID for inner diameter. I'm basically just going to build what's already in yellow here, but I'm using different variable names. Then for the units, this is what's nice. We can give it the units. I want these to be in centimeters, and for inner diameter, also centimeters. Then we can put some numbers here. And the engine operates not just on scalar values, it operates on vectors and arrays. So what happens here is OD becomes the name of a variable that stores the left column with units of centimeters. So when we type OD equals, we're going to see those numbers. It's going to be a vector, a math vector, and it's going to have units of centimeters. Now, of course, when we display it, it's going to show us meters because we're in SI and meters is the default. We're going to change that to centimeters. And then the same thing for ID. We're going to change that to centimeters. So these are vectors. OD and ID are vectors. Now we can loop over those elements in those vectors and calculate for each combination of diameters our shaft speed. So that's what we're going to do. So this is the input table, again, new in Mathcad Prime, not in Mathcad 15. And on the left-hand side, we have what's called a Mathcad program. And this is what allows us to do the looping. Now, if the nice thing about programming in Mathcad is that it does not require a pre-existing skill set in coding or in programming or in writing script. We have the whole point is that any engineer should be able to do a for loop or a while loop or an if statement in Mathcad without knowing VB script or C Sharp or any other programming language. It doesn't require knowledge of programming. Okay, there's no compiler, there's no real syntax, and on top of that, all of the math inside the program is in natural math notation. So we can include the natural math notation inside the program. Okay, this is a tremendous advantage because inside the program, typically when we look at code, it's a foreign language, except to the people that understand how to write that code. But in Mathcad, we can look at this program and we can see what the equations are. We can identify errors or validate them inside the program. So here's the program. On the math toolbar, on the math tab, in the center is the programming button. This is what we need. So to create this program, let's get rid of all of this ad hoc work that we did. So my cursor is here now on the right-hand side, about 2/3 of the way down. If we come to the programming and we click on the programming construct here, we have started a program. Okay, so that's how we start a program. And then to do a for loop, we just click on the top input there and we click on for, and it puts this in for us. So then we can just define our looping variable I, and we say we're going to start at 0. We're going to loop until we get to the last row in outer diameter -1. And now we've just written a for loop. So we're looping from 13 down to 10. And we're also then going to loop from 6 up to 9. So we're going to loop over all of the outer diameters in the vector, loop over the inner diameters in its vector. And for each combination of diameters, we're going to calculate those 3 things: the second moment of area, the stiffness coefficient, and finally the shaft speed. And then we're going to get 16 results instead of just 1 result. So that's what this program is doing. You can see the 2 for loops. I just showed you how to create those. And then we calculate the second moment of area. You can see it's the same equation we used before, the stiffness coefficient and the critical shaft speed. And these subscripts, I and J, those subscripts refer to the location within the output array that we're setting, right? We're gonna calculate the stiffness coefficient or the critical shaft speed, and we're gonna build a 4x4 array of outputs, and we need to set the ith row and the jth column, and so that's what these are referring to. Then we also have a requirement validation here. Check. If our shaft speed is greater than our min, we pass, otherwise we fail. Our min is up here, 22,000 RPM, so that's a threshold, that's a requirement. And then coming out of here, we have 2 4x4 arrays, one for the shaft speeds and one for the pass-fail results. So let's scroll down. These are the results. Okay, and now we can look at this and we can say, okay, the upper left-hand corner, that shaft speed we pass, lower right we fail. Okay, but we need more meaning, we need more context. We want to know what the diameters are that produce those pass-fail results. So then we just apply some formatting. And so this is a collapsible area right here. this plus, this is a collapsible area. So this is a section in the document that can be expanded and collapsed. And when we collapse it and we print this, or we create a PDF output report, everything that is in that area will be hidden. It won't print, and it won't go into the PDF output. And so when we expand it, then it will print. Okay, so however we have it displayed here is how it's going to print. And new in Mathcad Prime 4, so in the latest release of Mathcad, we've added protection on these areas. So we can now apply passwords to protect these things. So if we want to send this file electronically to somebody, and we don't want them to see what's inside of that area, here we just have formatting. But we might have some company proprietary calculations in that area. We might have sensitive data. We might have comments that we don't want anybody else, our customers, to read. Whatever it is that we want to hide, we can put a password here, hello, hello, and then we can control whether we want to lock it so that people can't even expand it at all. It's truly collapsed and locked. Or do we want to lock it so that people have read access, but they can't change anything? They can expand it and they can look at what's in there, but they can't change it. Okay, so we can define how we want to protect. But if we protect this, now you're gonna see I'm trying to get in here and I can't. So there's nothing I can do with what's in here. All I can do is look at it. And this is a very useful thing if you have engineers that are joining a project, joining the company, and you want to give them a template and have them design something, and you've already validated the equations, the lead engineers, the chief engineers have already approved everything. This is how we're going to calculate deflection. This is how we're going to calculate shaft speed. Put them in an area, lock it, then outside of the area, they can call those functions and execute those calculations, but they can't change the technical definition of the formulas and whatever else is in there. Okay, so that is new in Prime 4, the protection on these areas. That's new. Now, finally here, you can see we have the table of results here, okay, the frequency table, and then we have the pass-fail table. We don't have a lot of control over how we format those. We can make the entire thing, let's go to math formatting. We can make the entire thing bigger, we can make the entire thing smaller, but we can't highlight, for example, the diameters, the labels across the top, the labels going down on the left-hand side. We can't format those separately. So in order to create something that looks really good, we're going to send all that data into an Excel object. And when we do that, so what we're seeing here is an Excel object. Let me go back up. Okay, we're going to send all that data into this Excel object. So here on this Excel object, first of all, it's embedded in Mathcad. If we double click on it, it's going to open Excel with that data. And then any changes we make here are going to come back into the Mathcad document display. So if we want to highlight those and we want to highlight these, and we close this, everything we just did is going to come back into this display here. Now we can see the highlighting we just applied. And so to get the shaft speeds and the pass-fail arrays into this Excel file, we're going to expand at the top. If you follow my cursor, I'm on the plus. I'm going to expand that. And this is a section for inputs. These are inputs from Mathcad to Excel. Okay, the Excel object is a very useful tool to be able to integrate Excel with Mathcad and configure inputs and outputs. We have inputs to Excel and we have outputs from Excel. Okay, and we can embed the Excel spreadsheet inside the Mathcad document. We can read data out of it We can send data into it. We can have Excel do whatever Excel wants to do. Okay. Now, here's how we do it. This keyword Excel, that's a keyword that refers to this object. So we would just type Excel, then use a subscript and put the index where we want to start writing. So B3, and then we're going to say into that location, we're going to send in and subscript C and so on. So this is the shaft speed data. And then that goes into starting at B3. And so that's how we set this up. And so then I don't think we have any output. So if we want to read anything out of Excel, then we would set it up here. We would say coming out of this Excel object location, I'll just read out a G50 because it looks like we're sending an 800 into G50. G50, we want to assign whatever's in there to a variable called out. Okay, so then we can close these so that people don't have to see that. And then we have this. And what we've done is we've sent these two arrays in here. And in Excel, we can do all of this, right? All of this custom formatting. We can put a title at the top. We can label the rows, label the columns. And we've also done conditional formatting because we can do that there. If we pass, we're green. If we fail, we're red. So if we double click on this and go to conditional formatting, this is where we've set that up. So now if these numbers change and maybe the threshold changes on our requirement, our pass fails are going to change. This is going to update, and we don't have to actually open the object for this to update. So if we go back up here, let's just take a mental look at this. We're failing the lower two rows and then the right-hand side, the third row to the right. So then if we just go up here and we change some of these, right, let's just make these a lot bigger. Okay, that's probably good. And then that's probably good. So we've changed the two outer diameters at the top. And let's go back down here. And now you can see we used to have a fail over here, and now we still have a pass. And when I did this, I manually, here's Excel, I manually wrote in these diameters. But what I really need to do is automate those two so that they update if we change the input table. Okay, but you can see we didn't have to open Excel to see this table update. It just updates. It's all automatic. Okay, so a couple new things in Prime that we didn't cover. Let's go over here. So this is a blank document. Couple things that we didn't cover. I want to say, let me just write them down. So new capabilities in Prime 4.0. Okay, so area protection, we talked about that. And the embedded, not embedded Excel, but embedded objects in general. Okay, that's new. And equation wrapping, that's new. And I guess I should also say Windows 10 support. So this is completely supported on Windows 10. Okay, so there's a short list. We talked about area protection. Embedded objects I want to show you because embedded objects are actually quite useful. So embedded objects, let's go to input output. Here we can embed an object inside Mathcad, just like we embedded Excel inside of Mathcad. And I'm going to go down so you can see all of these objects. We can put an Excel document in here, PowerPoint, Word. So that's useful if you have a requirements document and it's in Word or PowerPoint and you want to embed it here so that you can double click on it and have quick access to it. Let's just go to Paintbrush and click on OK. So that opens Paint. And so now I'm going to just create, let's see here, a simple little sketch. We don't have a sketching tool in Mathcad. So let's just make a little sketch here. Oh, sorry. These are my these are my painting skills. Okay, so let's just start with that. So I'm going to close this. And so now here's the object. Here, we'll move it to the right. So there it is. If I double click on it, it's going to open Paint. And now we can change it. So let's just go add a line to this. And so whatever we do here, what's cool is that we see it update, and you can see my drawing update over here. So let's close this, and now there it is. Okay, and then this can be, you know, sized. And so that's those are the embedded objects. Okay, so they let you embed objects created with other applications inside the native Mathcad document, and then have immediate access to edit them by double clicking on them from inside Mathcad. When you double click, it's going to open the authoring application, make your changes, and then close. All right, so that's that. I also want to talk about equation wrapping. So in the past, if we had long equations, they would just go off the page, right? So I could write A plus B plus C plus D plus E. And if I would keep going, let's make this bigger, it would just go right off the page, okay? So now we can actually force the equation to wrap to the next line. And the way to do that, we're going to go to the Math tab here, go to Operators, and here there's a couple of different equation breaking options. So we can wrap on a plus, the four basic operations, the minus, the multiplier, or the division. Okay, so if we go here to the plus, then we wrap, it's going to push that to the next line. And we get this arrow, okay, that tells us we're going to the next line. So, so that's the equation wrapping. And so, there, that looks better. So that's new in Mathcad Prime 4. Okay, that's been just delivered in Mathcad Prime 4. So now I think we've talked about these things. So let's talk a little bit about working with Excel, because that's important. So we took a look at the Excel object. First of all, whenever we're working with Excel, we need to be on the Input-Output tab. This is where the hooks are. So we have two buttons, the Read Excel button and the Excel component. So we already took a look at the Excel component. We can come back to it if we have time. Let's look at this button, Read Excel. I'm going to click on this, and this is going to let us browse for an Excel file that we want to bring data in from. So we're going to browse, and then we're just going to go to an Excel file. So we're just going to use this generic one. Okay, this is time velocity acceleration data. Click on Open. This is very small data set, 9 rows, 1 sheet. If you have multiple sheets, you'll see them here. You click on the one you want. You can specify your columns and rows if you don't want the whole thing. Click on Insert, and this is what is important to understand. It will put this Read Excel function in for you, along with the path to your Excel file and the sheet and the range. And then we have to assign this to a variable. So we have to assign this to a variable. Now that variable is an array. It's an array in Mathcad. So we can look at it, my data equals, okay, and that is the Excel data. So this is linked to Excel. It's linked. Every time that Excel file changes, this is going to update. Now that we have the data here in Mathcad, we can do any kind of math that we want with it. Okay, so maybe first of all, if we want to calculate distance, we're going to multiply time times velocity. So we have to get rid of that header. We can't have those headers on there because we can't multiply strings. So instead of sheet A1, we'll start at A2. And now we just have raw data. And then we can create a time vector. So that's going to be from my data. So now we're going to hop over to the matrices. From my data, we're going to pull out the left column. We're going to add units of seconds to that because we know the units are seconds. And then we're going to create a velocity vector. So from my data, We're going to pull out the center column, and we're going to add units of kilometers per second. And then we can calculate distance, and that's going to be time multiplied by velocity. Sorry, this should say velocity. And so now we just created a distance vector. Okay, and we can look at it. We can look at that. Let's scroll down. So we can type distance equals. Sorry. If we're multiplying two vectors by one another, like we are here, Mathcad will actually take the dot product, because theoretically in the math world, that is what we're telling it to do, take the dot product of two vectors. We don't want that. We want a practical calculation, an element by element calculation of those two vectors. So we have to tell it, don't take the dot product, do an element by element calculation, and so we apply this vectorize operator. And now we'll get our distance vector, and of course we don't want meters, we want kilometers, or maybe we want miles. So that's how we do this. Okay, that's how we bring data in from Excel. It's really simple, really straightforward. We just use that button on the Input Output tab, click on Read Excel. And this Read Excel function that we just used, let's go to the functions. These are all the functions that come with Mathcad. Here they are on the left-hand side. That Read Excel function is underneath the category called File Access. So right here, there's a File Access. And there are a lot of functions in here to read and write data from other files. So this Read Excel function is the fifth one down on the list. That's the same function. So we could have easily typed Read Excel. We could have typed it, and we could have opened the parentheses and given it the path. But with the button, it's a lot easier. So we're providing a button for Read Excel. That's the only function in this list that has a button. Okay, it's the only one that has a button. But if you want to read Excel or read text data, here's a read text function. Just type it in, give it the path to your file, and read in your data. Okay, there's read CSV, read binary, and then all of the write functions too, writing a text file, writing an Excel file. So on top of that, we have a lot of other read functions. Okay, reading wave data, RGB data. There's just a lot of different reading data functions in here. So read Excel and perhaps read text are the most popular ones. You can type them in, or for Read Excel, you can use this button here. And Excel component, we already saw the Excel component. The Excel component will let you embed an Excel object inside the Mathcad document with inputs and outputs. Okay, so that should look familiar. We can activate it. We can do whatever we want to do in Excel. Okay, there's that. Cancel. So here's this. Okay, that's, maybe we want to make it bigger. Okay, we can do whatever we want. We're going to close this, and whatever we do comes back here. So if we want to read an output, let's go in here and do a calculation. In D3, this is going to be A1 times 45. Okay, we want to read that out. Let's make it red. So now let's close this. D3. So we're going to come here. From this Excel object, location D3, we want to assign that to output. And then down here, we can type output equals, and it's going to give us whatever's in that cell. So now we can say, going into this Excel object, A1, we want to drive that with a variable. Let's just say it stores a value of 25. I'm going to hit enter. 25 is going to go to A1, and D3 is going to update. Okay, so it's pretty slick. So we can close this. Actually, let's do this. Let's move this down. Let's define alpha here, and alpha is going to be 25, and then we'll drive this with alpha. Okay, and now let's collapse our inputs. Let's collapse our outputs. Okay, we'll just display this output number here. And now let's change alpha. We'll change alpha to 35. And then the output updates. Okay, or maybe just something totally different, the output updates. So that's how the Excel component works, and that's how the interaction with Excel goes. Okay, I think the last thing that we want to talk about real quickly is converting files. I know that's important to a lot of people, so I'm going to just show you how to do that. We're going to go to the Input-Output tab. There's a converter here. So this will let you bring in your existing Mathcad 15 files. Oh my gosh. This will let you bring in your existing Mathcad 15 files into Mathcad Prime. And what you need to do is run them through this converter. So we're going to add worksheets. Okay, and we're going to select a file that we want to convert. So I'm just going to select this one here, heat pumps. And you can see it's a Mathcad 15 file. And let's load it into the converter, and you can put a lot of files in here. And let's click on Convert. Now, this will leave the original Mathcad 15 file untouched. It's not going to change it. It's not going to edit it. It's not going to delete it. It's going to remain untouched. And it's going to create a new file in Mathcad Prime. And it's going to put the new file in the same directory as the original. So it's going to create a new file in Mathcad Prime, and it's going to save it automatically to the same directory. And so now you'll have two files in that directory, your original and the new one. So it says it converted, and then down here we get a quick log of notes from the converter. So it just tells us there were some formatting changes, you know, some other things that changed. Now, you can read this if you want, but what's more useful than reading this is to open the new file in Mathcad Prime, and it's going to be redlined. It's going to have annotations wherever, let's go find it. I'm going to open it. Actually, let me show you the original. This is the original file that we converted. This is, you can see it's Mathcad 15. And so this is what we've converted, just to give you an idea. So let's go open this in Mathcad Prime. And so let's see here. It's going to be redlined. It's going to be redlined. And so that's more useful than reading those notes, because you can go through this redlining and you can look at what all of the differences are. So this is a new file, heat pumps, okay? And if we look at the stamp, it's 37848. So that's, you know, that's where I am, 378, it's 850. So let's click on open. All right, and now here it is. And you can, these are the red lines I was talking about. See this red bar here on the left margin? That says there's something in this section that changed. And then the right arrow on the right points to the line. And then you can click on here and it'll tell you there was a formatting change. The superscript was lost during conversion. So it's talking about the superscript for the 30 degrees Celsius right here. Okay, that's the 30 degrees Celsius, 116 degrees Fahrenheit. So the superscript is the degree. So that was dropped. And the reason is because in Mathcad Prime, we don't yet have superscripts. We don't have them yet. So that's why. And so we can go through this. Okay, and you can see that all of this stuff is okay. Here's another red line. We click on this, and again, it's a subscript here. The subscript was lost during conversion, so Q, CT is the subscript. Okay, and so it's not in subscript form in this text box. So in Prime, we don't have subscripts in text boxes. We have them in math, but not in text. Okay, and that's why. That's what the message is. Now, all of your numerical results will convert just fine. Okay, all of the numerical results will be the same. There's not going to be any differences there because the math engine is the same engine. You can see question marks here. That's because when we open this the first time, brand new file, open it the first time, it's just giving us the raw conversion, okay, but it hasn't calculated yet. So the first time we're going to calculate this kind of hangs a lot of people up. We're going to go to calculation and we're just going to calculate, and now all these things will update. Okay, so that looks better. So we're going to go through this. Okay, this is another subscript. This one's another superscript. So you can see there's no problem with the numerical results. All the numbers are good. And when we're done processing this, when we're done going through it and just making sure we're comfortable, then we're going to go to the Input-Output tab and we're going to clear those annotations. Just clear them. It'll turn all of the red lines off. Okay, and you have to do them all at once. You can't go through one by one and say, okay, I validated this, clear it, and then go to the next one. You have to do them all at once. And so there's that. And then, of course, we want to do a couple other things. We want to apply the grid because that looks nice, and maybe add a header and footer. So then now we're good to go. So that's how we do our conversions. And there are some discrepancies between Mathcad 15 and Mathcad Prime. And so when you convert, you're going to get those messages, okay, if there are any discrepancies. So I think that we should probably just take one quick minute to talk about Mathcad Prime 5, and then we can open it up to Q&A. So Mathcad Prime 5 is going to be all about the plots and closing the gaps on the plots. Okay, there are some things missing in plotting in Mathcad Prime right now. And so if we put in a plot, you can see here, I'll just do a quick one. We can plot the sine of x. So we're going to put x here on the x-axis and the sine of x on the y-axis. And there's our plot. The thing is, we can't put a title here. We can't label the axis with a description. There's no legend. There's no grid lines. So Prime 5 is going to be all about closing those gaps to these plots, okay? Adding a legend, adding a title, putting on grid lines, adding a second y-axis. So in Prime 5, on the Math tab here, there's a chart component. So we can put in a chart component. We'll still have these original plots, okay, that the one I just made. That will still be possible in Prime 5. But we're also going to have this charting object. And now here we can say, and I don't really remember the format to do this, but here's our plot, okay, and we can say, well, I don't remember the format. I think the x-axis is like, let me try with the right-click menu. Okay, insert x-axis expression, that's going to be x, and then insert y-axis expression, and that will be the sine of x. And then we're going to have the plot. Now, we can actually, it's an object, so we can double click on it. And now we have a whole lot of things we can do with this plot. You can see we can add a legend, we can add a title. So I'm going to give the plot a title. Sine wave, put it at the top. So we have a lot of control over where it goes. And so this is just, a quick sneak peek at what we'll be able to do. And so now, I want to get out of here somehow. Let me move this. I can't see my button to get out of here, but here, so anyway, here we are, okay? And so then once we get out of here, this chart is going to display in the native Mathcad document, just like the Excel component displays, just like the paintbrush picture displayed. Whatever we do here on this chart is going to display as we've customized it using this charting application. And so Prime 5 is going to be focused on plotting for 2D plots. We're going to have grid lines. We're going to have a secondary y-axis. We're going to have titles. We're going to have legends. We're going to have all of those things and more. Actually, you can see there's a lot of cool stuff in here. Putting a border on your plot, putting a background on your plot. Okay, and that's just for the overall look. Okay, and then we can go to the x-axis and we can customize that. Go to the y-axis. So if we want grid lines on the x, we're going to apply grid lines on the x. On the y, we're going to apply grid lines on the y. So that's how this is going to work. Okay, we can go to the title, y-axis title, x-axis title. Okay, so it's going to be very good. It's going to be very good. And that's going to be really the foundation of Prime 5. Okay, all right, so I want to just hand this back over to Shannon, and then we can take Q&A. So thank you everybody for joining today. I'm going to transfer this over to you, Shannon, and I know you have a couple of things that you want to say, so go ahead.
Yeah, thank you, Angie, and thanks everyone for taking the time out of your day to attend. Really appreciate it. I did also want to mention 2 promotions that we are currently running, and those are going to be through the end of March. On any new seats of Mathcad, we are offering an additional 10% off, and then we also have reactivation deals on licenses currently off of maintenance. If you'd like any more details on this, please reach out to me, and then I will open this up to any questions you guys may have.
All right, I guess that is my job. I will come in with the questions. The first one, Angie, I believe you addressed when you were talking about reading in outside data, and that was one pertaining to reading in text files in Prime. If there's anything else you wanted to add to that, you can. Otherwise, I can jump to the next question.
Yeah, I think we can go to the next one. I think we've answered that one during the demo. We would use that read text function to do that.
So the other piece kind of relates to the same, importing Excel functionality, and the attendee is wondering if they can use an Excel component to put graphs into Mathcad. So basically grabbing some of the rich graph functionality in Excel and embedding that into Mathcad.
Yeah, that's a good question. You can display your Excel graph in Mathcad. And so I think that's what you want to do. So in Excel, when we were going through that Excel component, I was activating and deactivating the component a lot. What I didn't explain is whatever state your viewer is in Excel, when you deactivate the component, that's what will display in the Mathcad display. So if you're in Excel and you have a graph, make sure your graph is within view, whether it's on sheet 3, sheet 4, sheet 1, but at the bottom, scroll down, make sure it's in view, then deactivate the component and go back to Mathcad. And in Mathcad, you'll be looking at the graph. So Mathcad is going to display whatever state you're in Excel when you click out of Excel and go back to Mathcad. I was always anchored at A1. Every time I deactivated, I was always anchored at A1. So we were always seeing the upper left-hand corner of what was in my Excel file. Okay, but if I was anchored somewhere else, that's what we would see.
That's a good piece of advice. So those little things that people may not know. So thank you for bringing that up. Where you click in the Excel file is very important. Projected launch date for 5.0, is that public knowledge yet?
I'm going to say, yep. Well, it's not public knowledge, but I'll go ahead and say here that it is going to be released in June of 2018, right, this summer.
Will subscripts be added to 5.0? Do you know if that's something that's on the roadmap?
It is not on the roadmap for 5.0. It is on the roadmap for 6.0. Subscripts. There's a workaround for subscripts. There's a workaround. And the workaround is in your text box. When you're in your text box, you can insert a math region inside the text region. And in the math region, you can do a subscript. We're missing the subscripts in text, but we have them in math. So inside the text, go to the ribbon, click on Math Object, and then you'll have math within text, and then put in your variable name with the subscript, and then click out of that math and continue with your documentation.
If
So that's
it's within a text box, if it's embedded within a text box, is it still going to drive math that's below it in the worksheet, or is it kind of freestanding? Okay, so it is still a math region. Got it.
It's not freestanding. It's integrated.
And then 6.0, that's probably a 2019 release.
Yep, 2019, hopefully summer, hopefully 1 year after the Prime 5 release.
Okay, there's a long question around the converter. The user is asking if future improvements will be made to the 15 to Prime converter that will actually grab onto page formatting, like margins and math regions, sizing and spacing, when moving from one to the other. I don't know if there's still development on the converter side that's going on. Is that something you have any insight towards?
Yeah, we are going to take another look at that. There will not be any changes until Prime 6. Some of that stuff is pretty hard to compensate for. But we are taking a look at it and making improvements to the converter so that there are, the formatting just comes across better. And so we are hoping to be able to address a lot of those things, hopefully in Prime 6.